Now let us start the third chapter, that is current electricity. This is the introduction of this chapter. Okay. So current electricity is a very easy chapter of class 12 science, class 12 physics. So now let me go to the electric current and the flow of charges. So first of all, let me consider a conductor. So this is my conductor. Okay. So in that conductor, there are many free charges. There are many free charges. Now when the current flows, that we know it from class 10 when we connect it with a battery. Okay. So I will explain more in detail in the next lectures. So let me consider this conductor is being connected with the battery with positive here and with negative here. Okay. So I am not considering any battery like this. So this is my positive terminal of the battery and this is the negative terminal of battery. This is how it is connected like this. Okay. Now there will be a generation of potential difference. What will be there? Potential difference between say A and B. So this is my point A and this is my point B. Next, what will be there? There will be electric field between A and B, right? The electric field, the direction of electric field, this E is from A to B. So this is the direction of electric field. You know that whenever there is positive and negative, then in between that positive and negative plates, there will be a electric field. For example, this is one end of the conductor and this is another end of the conductor, and it is my positive and that is my negative. So this is how it look like. Now what is the direction of current? The current is flowing from positive to negative. So this is my current I. The direction of current and the direction of electric field is in the same direction, but you know that the direction of electron is opposite. Okay, so this will come in this direction. Okay, this will come in this direction. I am making all this curved one, little bit of parabolic one, not the straight line, because when you study in higher classes, you will find that the path of the electron inside the conductor is not a straight line, it is a parabolic path. Okay, so there are so many things here like drift velocity, mobility, etc., which we will discuss in later classes, but this is the introduction part. So this is how it is flowing. The electron is flowing in this direction, okay, and the current is going in that direction. Now let me go to the how this electron, why this electron are flowing, because of two things. One is your potential difference, other one is electric field. Please remember, these electrons are flowing because of the potential difference and electric field. For an example, if you have two tanks, okay, you have tank 1 here and I will call this as positive, and you have tank 2 here which is negative. You connect it with a pipe here, then what will happen? The water in positive will flow in this direction. Why? This is high potential. This has got high potential and this has got low potential, and the wire will flow from this. The water will flow from this tank to that tank, isn't it? Now if I consider another thing, so if this is for potential, this is here, the current is flowing from, this current is flowing from A to B, that is, this is at high potential and this is at low potential. But at the same time, in fact, the electric current is in this direction, but the charges is in this direction. Why? Because of electric field. Now if you have this plate, okay, which is positive, and this is my negative, and here what is the direction of electric field? Electric field is in this direction, you know this, okay. So these are my electric field, direction of electric field, and if I have an electron here, okay, electron, it will experience a force. It will experience a force, and that force is equal to E into, Q into E, and this is equal to, what is there? There is electron and this charge is electron. And what is the direction of this force? The direction of force is in this direction. Okay, so the force here, this is force is in this direction. The force everywhere is in this direction. Okay, so the direction of force, this is force is in this direction, right? Because electron is a negatively charged particle. Now in electric field, if you put a charged particle, it will experience a force equal to Q into E. Now if it is a positive charge, then it will travel in the direction of electric field, but if it is a negative charge, then it will travel opposite to the direction of electric field. So direction of electric field is in this direction, and direction of force is in this direction. So the current is, okay, potential difference creates what? Current. Okay, and electric field creates flow force of charge. Force on charge, which ultimately gives the current. Okay, so this is all about your introduction. Understood? The potential difference gives the flow of current, and the electric field gives the force on charge, and that force on charge will give me the current, because current is similar. Okay, current is always similar to flow, isn't it? You see, some people say wind current, some people say water current. What do you mean by wind current? The flow of wind. What do you mean by water current? Flow of water. Okay, so whenever I say electric current, then whenever I say electric current, this is my electric current, then this electric current represent to the flow of charges, isn't it? This is my flow of charges in electric field, not in the potential difference. Potential difference, because of potential difference there will be a flow of current, and because of electric field there will be a flow of charges. Okay, in both the case it is always there is no big difference between flow of current and flow of charge. In fact, flow of charge is also a flow of current. Okay, but in class 10 I have to go to a bit deeper part. That is why I am saying all these things. Now let me go to define the electric current. Okay, so electric current, the flow of charges is because of electric field. Okay, electric current is because of because of electric field there is flow of charges. Because of potential difference there is electric current. Now see current. What is current? Okay, now if you have a gate here, let us make a gate here. Okay, let us make a small gate, and we count. Okay, and in 1 second how many electrons is coming in this direction? How many electrons are coming in this direction? See, why electrons are coming in this direction? Because electrons are negatively charged particle. Okay, and the direction experienced by each and every electric charge, that is electron, the force, okay, the direction of force is opposite to the electric field. So electric field is in this direction and force is in this direction. That is why electric charges, which is electron in this case, is coming in this direction. Now in 1 second how many electrons will pass through this gate? That is my flow of charge, and that is my current. So this is equal to, the current is equal to flow of charge. Okay, flow of, I will just write electron per unit time. Okay, so current, I is equal to then E divided by T or Q divided by T. I am not putting the negative sign. What is Q? Q is charge. Now if there is some other charge, say any other charge. Okay, if there is if the protons are flowing, then there will be a current. Okay, if ions are flowing, there will be a current. Okay, if any charged particle is flowing, then there will be a current. But in conductor, what is flowing? The electron. So I will just write I is equal to Q by T. So then what is SI unit of current? Is this is charge, that is coulomb per second is SI unit. Okay, or the SI unit of current is ampere. AMPERE, or bracket में capital A. So this is all about your flow of charges and electric current. So rate of flow of charge per unit time is my definition, mathematical definition of current. Okay, now in next lecture we will go to the drift velocity and thermal velocity. Thank you.